YouTube now.
Hi, everyone. Welcome to this morning's session. We are so excited to have Professor Connor Walsh join us today. We'll give about 1 or 2 more minutes for everyone in the waiting room to join. In the meantime, our goal for this session is for you to kind of expand the realm of what is possible in your academic and professional futures. And we would love to have you be able to ask questions to each other, connect with each other, and also be able to ask questions to Professor Walsh. And so for us to be able to do that, we just wanted to set a couple community norms for the chat before we go ahead and get started. The first is the grounding value of Crossroads is compassion. So please at all times be kind and compassionate to your peers. Please don't be disruptive during the session. You can raise your hand and we can call on you to unmute you. And if you have any questions about the Crossroads Emerging Leaders Program and the semifinalist process itself, please save those towards the end. Your questions about Crossroads specifically, I will stay on to answer them at the end of Professor Walsh's session. So please focus your time on the subject matter of Professor Walsh's talk. If you have any questions about Crossroads, again, we'll answer them towards the end. You can also ask us on social media. So like I was saying, I'm really glad to have you all join us here from around the world. I know we have students from across Latin America, across the Middle East, all the way to Cambodia and the Philippines. And we're so excited to hear all of your different perspectives. Professor Connor Walsh is joining us today from the School of Engineering at Harvard. His interdisciplinary research spans engineering, industrial design, apparel, and medical communities to develop novel technologies that augment and restore human performance. And he's going to be telling us a little bit about that today. Thank you so much for joining us, Connor, and really excited to get started.
Great. Yeah, thanks TR as well for your efforts organizing this and the rest of the kind of group of people who are make Crossroads happen. I think it's a great program and I'm excited to be part of it today. So I guess I'll introduce myself briefly and I'll share screen so that you guys can see some slides here. And what I'm going to do today is kind of talk through some of the research that we've been doing at Harvard. So I'm a faculty member in the School of Engineering and Applied Sciences, and our research group is called the Harvard Biodesign Lab. And most of what we work on is in the area of wearable robots and wearable technology and medical technology. And so all of the work that I'll present today is really the hard work of graduate students, postdocs, some undergraduate students, as well as some research staff. And it definitely takes a big effort and a big team to do all of this research. So what I'm presenting today is really the work of a lot of other people who are working in our research group. And so I'll go through this, but I definitely want to encourage people to type a question in the chat. And, I'm definitely happy to answer questions along the way. I think it would be great to have this be as discussion focused as possible, rather than just me, talking all the time. And I'll definitely make a point of asking a few questions, kind of throughout the talk, just to kind of get you guys thinking a little bit more, and also to get your ideas on the type of research that we do in our group. So, mostly, what our group focuses on is developing self-robotic technologies that can be applied to medical applications or applications to help people. So we like to think about developing new technologies that can restore function after people have lost it. So if someone's had a stroke or a spinal cord injury, how do we help them get better? And if someone's had an injury, how do we help them heal quicker, whether that's a muscle injury or a brain injury? So we think about technologies that might help people there. We also think about how we can prevent injuries from happening in the first place. So if people are doing strenuous activities, how do we stop them from getting injured? And then we also think about how we can, augment people in general, because we're excited about the idea of how technologies and humans can work together to make humans be able to kind of perform tasks more efficiently or better than they would be able to on their own. And our research group has, a fairly diverse, set of expertise. So on the left here on the slide, you can kind of see generally the type of expertise that we have when it comes to research and development. So we have some people in the group who have mechanical design or manufacturing expertise, in mechanical engineering focused. And we have people who have expertise in electrical engineering and who work on, our embedded systems, creating circuit boards and programming microprocessors, creating software apps on phones. And we have people who develop new technologies and new sensing technologies. And so new ways of measuring movement or measuring pressure or measuring force. And then maybe kind of a little bit, non-traditional from an engineering school, we also have a fair amount of people in the lab who have an apparel design expertise, and in particular, functional apparel design, because for a lot of our technologies, we want to really integrate them into devices that can be worn and that people want to wear. And then we also work on control algorithms. So we work on, taking information from sensors and then being able to have that, send commands to motors or actuators and to be able to kind of help people move their limb as well. So that's kind of like more on the kind of like technical side. That's a big focus. One of the other things that we have a big effort on too is really thinking about kind of a user experience and product design. So, not only do we want to kind of do very cool research, but we also want to be able to, think about the user early on in the design process and make sure that the technologies and the devices that we're developing actually can be useful for people and actually help people. So, really that kind of falls under the general bucket of industrial design. And so we have some industrial designers in the lab who help, lead that effort on the project. And then one of the things that we use to kind of both guide the development of our work and also evaluate our technologies is, biomechanics and physiological measurements. So we have a very nice motion capture lab where we can put markers on people. We can monitor how people move without the device and with the device. And then, we also kind of are able to measure what their muscles are doing and to see if their muscle activity is changing when we're having them wear some of our devices as well. So that's certainly, another kind of area that we've built up a lot of expertise in and has been very important for our work. And then personally, and many people in the lab are motivated to not only write research papers, but also think about how do we bring these technologies to the people who need them. And so that's where kind of we have a little bit of a focus on understanding the market, understanding some business development aspects to make sure that there is a pathway to kind of have the technology leave a university setting or a research setting and transition more to industry. And so these are just kind of two examples of where we started. This is almost 8 years ago, and were two of the very first prototypes we had. On the left, there's a device that is applying assistance at the ankle to help people with walking. And then on the right is a glove that's, would help someone who has hand weakness. So these are very, very quick, early prototypes. They're not, very sophisticated. They don't look very pretty or elegant. But they definitely allowed us to kind of demonstrate kind of like, proof of concept that, using these types of soft robotic technologies, we would be able to apply enough force to either an ankle or to a hand to do something useful. So that's really kind of like where we started. And since then, we've been kind of working on refining those technologies. And the way we've refined it is by creating a team of people. So here you can kind of see a time lapse of our lab where you have people kind of working on the apparel aspect. You have people looking at, sensors and control signals. We have people who are creating kind of fully integrated prototypes that look a little bit more refined than the early prototypes that I showed there. And then after we have these prototypes, we then evaluate them in more rigorous, scientific studies. So that's kind of an overview, of kind of our group before I, get into details of the project. So I'm just curious if people have any high-level questions about the type of research we do, how we approach research, how we build a team for different projects. And I'm happy to kind of take a minute here and just discuss that, because it's probably one of the more important things about, research. And then, we can go on and get into more specifics on some of the projects along the way. So any questions from anyone on kind of how we organize ourselves?
I think in the chat, I'm seeing a lot of questions about the interdisciplinarity of your research. Diana, do you want to ask about that a little bit?
Hi, yeah, my question was already in the chat. I was asking about your research, Dr. Connor. and how applied mathematicians can, get into that kind of research. Are there applied mathematicians currently working in your team, and so on?
Yeah, that's a great question, Diana. Thanks for that. So I would say, our work is very interdisciplinary, and we have probably largely PhD students, postdocs, and staff who are working on these projects. But we also have undergraduate students who would be kind of participating in our research as well. And then, on occasion, but pretty rarely, we would have high school students. But most often it would be, undergraduate students who are kind of the most junior people, working on our projects. And when we look at these projects, it can sometimes feel very intimidating, right? There's a lot of different aspects. There's, a lot of different expertise that's required. And I think one of the reasons why I showed kind of those early, pretty crude prototypes is just highlighting that it can take a long time for research to kind of mature along the way. So maybe to kind of get to answering your question, oftentimes when people get involved in the lab and get involved in research for the first time, they come in with one particular type of expertise. So maybe they have mechanical engineering expertise, maybe they have a biomechanics expertise, maybe they have an electrical engineering or physiology expertise. And usually they're working on some specific aspect of a project and then collaborating with people who have those other backgrounds and disciplines as well. And so we usually do a pretty good job of trying to encourage teamwork, but also make it clear what each person on the team, and what their role is. So for someone who's kind of, more junior, which could be a new graduate student or, an undergraduate student in the lab, oftentimes we try and have, a pretty contained project that allows them to be able to kind of like learn, and contribute to our research at the same time. So, we've had students who have kind of built kind of mechanical designs, and we've had students who have, looked at kind of analyzing data from sensors, and we've had students who have helped with running some of our experiments and making sure that we design those experiments well and then collect data and then also analyze that data afterwards. But I would say, my advice to kind of young, students interested in research is, find a way to kind of get involved in a group and find a specific area that you want to kind of begin to help with and learn about. And then, it's surprising, but like over time, whether it's 6 months or a year, you can pretty quickly build confidence in that area. And then you can kind of move on to the next area and think about, okay, now I'm going to kind of take on a new challenge. And I think if you're in a good environment and a good lab, you'll be able to continually challenge yourself and learning new things. But oftentimes just starting with, a smaller aspect of a project and working with kind of people who are more experienced is usually a good way to get started.
Thanks, Connor. That was really helpful. And I think we'll take one more question from a student, if that's okay, before we keep moving.
Yeah, sure.
Cameron, are you able to unmute yourself?
Yes, thank you very much, Tiara. Thank you, Dr. Walsh, for coming and speaking to us today. My name is Cameron Knight. I'm a graduating senior at Hampton University in the Business Administration Department. And I'd like to know, how does the Department of Engineering and Applied Sciences plan to continue its R&D efforts and push these disruptive technologies to market? Thank you.
Yeah, that's a great question. I have one slide on that later on. So we look at our role so when you think about research and development, there's a spectrum there from very early stage research to kind of like very later stage development. We look at ourselves as being kind of heavy on the research side. And our goal is really to be able to demonstrate proof of concept from a technology point of view. So we like to build robust prototypes that demonstrate that something is possible and that maybe hasn't been, shown before. And then the other thing we like to do is we like to run a study with the target population. So whether that's with stroke survivors or another group, we like to run a study where we show on, say, 10 people that this device can help people walk 20% better. And that's really kind of like where we see kind of like our main, expertise and strength. Then what we think about doing is, okay, now that we've shown that this actually is valuable and that it works, how do we bring it to market? And I guess there's two vehicles for doing that. One is, and we've done both, one is to say, can we find an industry partner that is already working in this space, that understands the market, that understands how to go through the FDA process or any regulatory process? And so we explore licensing technologies to them, where they would then kind of get, work with Harvard to get the rights to the technology that we've developed. And then they would be the ones that would commercialize that. And then sometimes they would ask our team for some help because our team would really know the technology better in terms of transferring some knowledge to them. So we did that with one of our projects that we licensed to a company called Rewalk Robotics. The other approach is that maybe some team members who are working in the lab are very motivated in launching a startup. And so we did that last year, where there was a number of people who were excited about a startup on some of our technology for helping workers in industry. And so they basically worked with Harvard to license the technology, start a new company, talk to investors, get some investing money. And then they also launched a startup that is now over a year old and doing quite well and off to a good start. So I guess part of it is really kind of dependent on what makes sense for the technology and then what makes sense for the team of people who are working on it. But we definitely have a strong motivation for as many projects as possible to be able to transition to industry, because that's really where there will be the most impact. Good question.
Great. Thanks so much, Connor. I think students, if you want to keep your questions on your mind or send them in the chat, we will definitely circle back to them.
Yeah, and we'll definitely take a few moments kind of throughout the hour today. So definitely, keep those questions in mind, and maybe you'll be able to kind of bring them up at a later point as well. So the first project I'm going to talk about is our exosuit project. So this is a project that uses motors and cables to apply forces in parallel with the biological muscles. So when we walk, our muscles are turning on and off all the time. We don't even think about it. And that's what's helping us kind of propel ourselves forward and keep our bodies upright. So we started this project first thinking about how we would apply it to healthy people. If someone's walking for a long time carrying a very heavy backpack, they're going to get very tired and their muscles might get injured. So if we can apply these kind of like forces in parallel with the biological muscle, so you can think about it as an external artificial muscle, the goal was that the biological muscle would have to do less work and would see less stress, and that the person would get less fatigued when walking with these technologies. And so that's what you can kind of see in this video here. You can kind of see that we attach the cable above and below the joint, in this case here, the hip joint. And then we have sensors in the system that monitor how the person is walking. So we know what phase of the walking cycle the person is in. And then we're able to send a command to our microcontroller that then tells the motor to pull on that cable and apply forces at the right time while a person is walking. And we have a bunch of papers on our website that go into more details on this project. And so this is kind of, the final prototype of a big multi-year, 5-year program that we had, where we had a device that applied forces at the hip and the ankle joints while people walk. And we showed we could make it about 15% easier for people to walk when wearing the device compared to not wearing the device. So it basically helps people be more efficient. So the way that we measure that benefit is you can see that in the video, where we have a person wearing a mask, and that mask allows us to measure the amount of oxygen that a person is consuming. And so we're able to use that as a way to see how much less energy did the person have to expend because they didn't need to consume as much oxygen. And so one of the real benefits of this technology and why it was maybe new compared to what the field had done before is the part that is on the leg is very lightweight and very flexible. And so maybe I'll kind of ask everyone here, like, why do people think that was important? Why did we focus on creating something very lightweight and something that was very flexible? There's 2 reasons why. So let's kind of maybe have a bit of discussion around that.
Zainab, are you able to unmute yourself?
Hello, Dr. Connor. So I would like first to ask about how much can this exosuit help in the Parkinson, in the case of having Parkinson, and on the other side.
Zainab, I don't think we can hear you right now. Why don't we circle back to you, Zainab, if that's okay?
Being also flexible. It means that the person
Connor, I think I'm so sorry, Zainab, we will definitely circle back to you.
move in the way
Yeah,
that they want.
no
It's the same
problem.
as the body functionalities in a sorry, so that's
Yeah,
my thought.
Yeah, I could hear like a little bit. It was a little bit choppy and hard to hear, I think, just because of the bandwidth connection. Maybe one thing you could do is if you don't mind, maybe you could type the, question or answer in the chat, and then we can have a look at that. But it was a little bit just hard to hear, I think because of the internet connection. But definitely, I think I heard kind of what you were saying, and it sounded like a really good point. So maybe we can move on to if someone else wants to kind of give some ideas about why lightweight and flexible is important.
I know in the chat, Diana said to make it easier for users to wear. Sridhar said to keep the additional load on the leg as minimum as possible. Sridhar, would you like to unmute yourself?
Yeah, so what I was trying to say, like already we have additional load on the back. So if this adds more load, the user experience won't be good, right? So maybe for that reason, it was made lightweight.
Yeah, exactly. So, the two reasons are, the first is what you just said, is that, if you add additional weight to the legs, it, has a big cost. So I think if you add kind of 1 kilogram, to the waist, versus if you add 1 kilogram to the foot, I think it's 10 times more expensive to carry that, weight from an energetics perspective if it's on your foot compared to if it's on your waist. So you're very good at carrying, weight when it's close to your center of gravity or close to your waist or chest. And versus if you put that weight on your legs, you really notice it, and it really makes it harder to walk. So that was one reason. And then the other reason is that, we're all optimized to walk pretty efficiently. And if we had a rigid kind of structure around the legs, that's going to be very hard to kind of line up with the kind of biological joints. And so that would add some restrictions and make people walk kind of like in a slightly different way. And we found in our research that if you disrupt people's natural walking pattern, that really kind of makes it feel uncomfortable and adds a lot of cost to them as well. So the main goal for this project was, let's put most of the weight of the system, close to the person's waist, and let's keep the part that's on the leg as lightweight and flexible as possible. So, good answers and good points. So we'll keep moving on, and then, we'll kind of have some discussions around some other aspects of the research as we move forward. So we've also kind of started to think about how we can demonstrate that we can help people in more unconstrained activities. So we had a nice paper come out about 2 years ago that showed we could help people, not only with walking, but also with running. And so this was the first time that, someone had shown that we would, are able to do that. So that was a kind of really nice finding for our team. But one of the things that I want to spend a little bit of time on today is how we adapted that technology that we started looking at, augmenting healthy people, but started looking at how we would be able to restore mobility for people who had suffered, some type of impairment. And specifically, we've been working with people who have suffered a stroke. And so you can kind of see here kind of like a prototype of, the exosuit for that application. And really our goal here is to enable, people to recover better. That's really kind of our goal. And so if you look at this graph, when someone suffers a stroke, their mobility takes a drastic hit and they really kind of end up being very immobile. What happens traditionally is they then kind of go to rehab and they get some help and they get a little bit better. And then they eventually kind of go home and they're encouraged to continue to practice their walking when they go home. But unfortunately, kind of people don't have the capacity, to walk very well. And so oftentimes they don't practice that much and their mobility goes back down. So what we would love to do is say, can we help people walk earlier and walk better while they're in a clinic? And then can we actually have a person go home with the technology that allows them to continue practice walking better in the community and the home, so that we can actually keep them, at a better level for a longer period of time. So this has been a big project in the lab over the last 6 or 7 years. So this device here only kind of targets kind of one leg of the person, because oftentimes when someone suffers a stroke, they have one leg that's much more impaired than the other leg. And what we're doing here is we're targeting the ankle joint, because the ankle joint is oftentimes the most impaired leg of a person who suffers a stroke. So this is our motion capture lab. This is one of our volunteers who comes into the lab. They're wearing our exosuit. This is our clinical collaborator, Lou Awad, who's a physical therapist. who kind of helps us understand kind of like pathological gait or kind of impaired gait for stroke survivors. And then we study, how these devices can help people both when they're walking on the treadmill and also when they're walking over ground as well. And so the way this device works is pretty similar to the other device I shared, where we have sensors that monitor kind of how the person is walking, and then we apply forces with these cables to basically allow the person to have better ankle function, while they're walking. And so from a science perspective, how we kind of quantify the benefits of these devices is that we run experiments, and we would bring in, 7 to 10 stroke survivors, and we would have them walk, and we would compare two conditions. The first condition is we would have them just walk normally, so not wearing any device, at all. And we would quantify what is their baseline ability or what is their baseline impairment. And then we would have them wear our device, and then we would see how does their movement change, how does their symmetry change, how does their energy cost change, how does their kind of propulsion change, so how hard are they pushing off on the ground to move themselves forward. And so we would then kind of be able to kind of compare the data from those two conditions and be able to quantify, how much the device actually improves their walking pattern and their gait. And so we do some of those studies on the treadmill, but then we've also developed portable systems that people are able to wear over ground. And so here you can kind of see this lightweight pack that is worn around the waist. It has two motors inside there. It has the electronics. And then the person also has a battery around their waist as well. And then it has the cables that transfer forces down to the ankle joint. And then I'll just show this side-by-side video, and then we'll take a quick break. So this is just one example of a person walking over ground. And we've run some studies that show that we're able to help people walk faster and walk further when wearing these devices compared to when not wearing the device as well. So not everyone responds as positively as this person here. Some people, don't walk much faster when wearing the device, but some people certainly do. So we see a need to continue to understand a person's individual challenge and, tailor and adapt kind of technologies, to them. So I'll take a break there and see if people have any questions on this technology. And in particular, one of the things that I might kind of ask people is, what do you think would be some different considerations from a research point of view when working with a patient population like stroke survivors compared to kind of working with, kind of healthy people who might be members of our research group?
One of our students, Omima, sent in the chat that they're actually a physiotherapist. And so I think they have experience working with hemiplegia and SCI. Those are things they mentioned. Omima, would you be open to responding to the question?
Yeah. Hi, I'm
Hi, we
Omima.
can hear you. Yep.
Who is asking?
So you mentioned that you're a physiotherapist and you work with.
Yeah. What's your question?
Are you able to share a little bit about your experience working with patients with neurological conditions?
Yeah, I will take about. We use it in neurological condition to restore their neurological function, like sensory integration, sensory input. They increase the ability to return to normal life again. I will share in the group. Wait.
Yeah, thanks so much for that answer. And I think that's a really good point. So for our research, when we're working with a patient population, we definitely work very closely with our clinical collaborators who often have a physiotherapy or a physical therapy background. And so we definitely rely on them, to help us with recruiting individuals for our studies. So, finding people who might be volunteers who might be excited in participating in our research. And then also, this is Regina, who's one of our team members, who, is also then makes sure that the, participant feels comfortable with all of the different things that we want to try. Because our research is still very experimental. And so we definitely want to make sure that we follow, good safety protocols to make sure that our participants feel comfortable participating in the research. So oftentimes, if a person is walking on the treadmill, we might have a harness just from a safety point of view. Or if they're walking over ground, we'll have the physical therapy team member, follow them closely just to make sure that they feel comfortable, walking over ground and using our device. And then one of the other things that we have learned is that there's a much greater variation in terms of people's walking ability and walking pattern for people who have some type of physical impairment compared to kind of, normal, healthy people as well. So I think it's really important that, before we even evaluate any of our technologies, we really understand what people's specific individual challenges are and make sure we understand that, before we kind of jump into the experiments. But that was kind of great perspective, and thanks for sharing that as well. So any other kind of questions or thoughts on this aspect of our research before we move on?
Zainab, who was speaking before, is a biomedical engineering student, and her question is, how can these devices specifically, I think, which is kind of what you just answered, but specifically help in the case of neurological diseases? And Zersh, feel free to pick any. Zersh is asking, how do you observe differences? How do you identify those differences that you mentioned between the healthy population and between the patient population whose walking pattern is different?
Yeah, so they're kind of great questions. So when someone suffers a stroke, I'll answer the first question first. They often have kind of challenges with coordinating kind of like the control of their muscles, at their, more impaired leg, and so their paretic limb. And so oftentimes it's most challenging at the ankle joint. So essentially, you can think about when someone suffers a stroke, the muscles at their ankle joint, so in their calf and at the front of their leg at their shin, those muscles just aren't functioning correctly, which means that oftentimes they would have a challenge of not being able to kind of push off on the ground, with as much force as a normal healthy person would. And that force is important because if you want to walk forward, you have to be pushing off the ground to kind of propel yourself forward. And then the other challenge that they have is related to making sure that their toes don't drag on the ground. So, oftentimes, those muscles are weak, so the toe can drag, and then that can lead to a trip hazard. So essentially what we're doing with the exosuit is we're able to mechanically kind of like help restore some of that lost function. So we can apply a force kind of at the back of the calf that helps lift the heel and helps the person push off on the ground. And then we can apply a force at the front of the leg to be able to kind of pick up the toes and to make sure that the person's toes clear the ground. So the benefit for a person is when they're walking, now their ankle is able to function in a more normal manner, which allows them to walk in a better, more normal way. And one of the things that we're very interested in is if we're able to allow people to do this and practice this, could they practice better walking, when wearing this technology, so that eventually they might be able to walk without the device in the future as well. So for most people, a big part of recovery is doing rehabilitation and doing practice. And so they would normally work with a physical therapist on this. And we hope that our device might allow people to practice better walking, more intense walking, longer walking, and that will just help them get, speed and more quickly towards kind of a more normal walking pattern without our device in the future. So that was kind of the first question. And then I forgot the second question, but it was a good one. I don't know if you can remind me, Tiara.
Yes. So Zersh was asking, how do you identify the differences between how the healthy population walks and the patient population's walking pattern?
Yeah, that's a really good question. So I think a skilled physical therapist who sees a lot of patients is able to very quickly see which part of the person's walking looks different from normal. So maybe their toe is dragging on the ground. Maybe they're not spending as much time on, the leg that is more impaired because they don't feel as strong or as stable on that leg. So they might be relying more on their healthier leg. Maybe their leg doesn't go as far behind them. Maybe they kind of step, less in a kind of a, have a shorter stride length. So maybe they don't take as big steps. So they're kind of things that a physical therapist would observe. the way that we measure that and quantify that is we can put markers on a person's body. So we can put markers on the foot, markers on the leg, markers on the waist, and we can actually then measure, what are the angular changes, that a person would have, and compare that to, a normal person. So maybe their ankle doesn't move quite as much, or maybe their knee stays locked and doesn't bend while they're walking. So we can actually kind of measure those kind of geometric or angular changes, and kind of see how people's walking would be different. And the other thing that we can do is we can, what you can see here in this picture are these kind of squares in the ground. Each of those squares is actually a force sensor. So we can measure how much force a person is pushing off on the ground with those force plates. And so we can see kind of how much less would a stroke survivor be pushing off the ground compared to, a normal person who would be walking over those force plates as well. So we try and use, these quantitative tools to capture these differences in walking patterns. That was a good question. So I'm happy to take one more question here, or we could move on. Either works fine.
I think maybe one more question, if that sounds good, Connor. Marcus is asking, how does the team think about the power consumption and power supply of the system? What if the power runs out and the actuators stop?
Yeah, so that's a great question. I would say one of the biggest challenges in wearable robotics in general is making systems lightweight but still powerful. And that's a challenge. And there's two main reasons for that. One is the motor technology, basically kind of sets a constraint on, you need a certain size motor and a certain weight motor to generate enough force and, to be able to apply to the person. And then it also, requires, a battery to power those motors. And the bigger the motor, typically the more power it consumes, which means that your system gets heavier. So we actually start doing a lot of our research, without building a portable system. And we try and understand what is the most efficient way to apply force to the person. And then basically kind of understand how to then, have the smallest, most lightweight system that can, still be beneficial to an individual. And then one of the benefits of our approach is that, if the power, battery does, die or run out of power, and the device is not too heavy. So, a person can typically still move around when wearing the device. It doesn't add a lot of burden, and it doesn't add a lot of restrictions to the person's movement. Maybe they'd have to move slowly, but I think they would be able to move around. And we're also kind of thinking about, in the future, how would we make it so that people could easily take this technology off, in less than a minute, so that, maybe they would be able to kind of quickly take it off, if the battery did run out. But it's definitely one of the big challenges, is making these systems both powerful enough, but also efficient enough so that the battery doesn't need to be too big. That's a really good question. So I think I'll keep moving on, and then, definitely please jump in, if there's more questions later on. So as I mentioned, and someone asked a really good question earlier, this is one technology where we decided to partner with an existing company. So after we, had developed the technology and shown exciting proof of concept, study, in the lab, a company approached us called Rewalk Robotics, and they saw the potential for this to be an extra product that they added to their company product line. So they licensed the technology from Harvard, and we worked with them to kind of transfer our knowledge. And so they now have a product called the Restore Soft Exosuit, that's being cleared for use in the US and Europe in clinical settings. And so it's really exciting for our team to see that kind of the early stage research that we developed in the lab is now actually being used in clinical settings for people. We're still interested in how do we, continue to evolve and advance this technology. And so, like I mentioned already, our main focus so far has been devices that get used in the clinic, but we would really love to have devices that could be used in the home or in the community. And so this is one, video of one of our volunteers showing a more recent prototype that we've developed, where we're really trying to think about making it accessible enough so that a person would be able to kind of don and doff or put on and put off these devices themselves, knowing that these people oftentimes have some type of impairment to one of their hands, in addition to you know, their leg as well. So we put a lot of time and attention into thinking through, you know, how to make these devices usable enough so that people would be able to kind of wear these themselves, and not always have to rely on another person to be able to help put it on or take it off. So I'll transition on a little bit to kind of you know, another area that we focus on. So this is kind of a soft robotic glove. So it uses a different approach. We don't use motors and cables, but we use kind of balloons inside textile garments to be able to inflate and deflate kind of devices to apply forces to a person's limb. And so here you can kind of see one of these gloves. It's very much like a regular glove, but it has bladders inside it that we can kind of control with a pump, and when those bladders get inflated and how much they get inflated, you know, as a person is wearing them. And so for this project, we've also been working on it for many years. I showed that first video at the start. And so one of the things that, you know, I think is worth highlighting in this talk is that, you know, research can take, you know, a long time. And so, you know, oftentimes we see the end result, and people don't always appreciate or understand that it's taken a long time to get there. And really, you know, it's about making kind of incremental progress or small progress along the way. And then all of that progress eventually kind of adds up to, you know, an exciting kind of like end result. So we've had many different prototypes using slightly different approaches over the years, and written a number of research papers on each of the different versions that we've developed and worked on. So this is this technology here, and you can kind of see it's like a textile. This is just one finger. When you inflate one bladder, it can stiffen like a beam. And then when you inflate the other bladder, there's two bladders inside here, it can articulate in this interesting way that mimics the behavior of a finger. So I might pause here and just ask people, you know, what do they think would be some of the benefits of this approach, where you're able to inflate these actuators and cause them to kind of take these interesting different types of shapes. So any ideas about why we think that these technologies are exciting from a wearable robotics point of view?
Just give everyone a couple seconds to type responses or raise their hands, and then we'll begin calling on students.
Sounds great.
Shoshana, would you like to unmute yourself?
Sure, Tara, thank you. And I do believe that this approach may help to innovate a mechanism which will help to save energy, like because having enough energy and not spending too much weight, as already discussed, is one of the key goals of the process, and this might be able to help. Also, it might be more convenient than having some metallic constructions helping people with the hand movements or stuff.
Yeah, I think really great answer. And, you know, for sure, you know, the first thing that you mentioned is for a lot of these people, if they have a weak hand, they also have a weak arm. And so if we add a lot of weight to their arm, they will find it very hard to be able to lift their arm. And then the second thing is, you know, you could certainly still apply forces with other means, like so using metallic structures or rigid mechanisms. But we also like the simplicity of these kind of textile actuators, where you can kind of keep the device relatively simple and then basically kind of program in some kind of intelligence into the materials. So here we're able to kind of choose the mechanical properties of the textiles so that when it gets inflated, it follows the motion of the hand. And so that basically allows you to kind of simplify the device a lot. And, you know, practically speaking, if people are really going to use these devices in their homes, having devices that are very simple and having devices that are very robust is really important. So that's another reason why we like this approach quite a lot. So I'll keep moving on. This is kind of an example video of one of our volunteers who had a spinal cord injury. So you can see here that he doesn't have, you know, very much hand strength, but then wearing this earlier prototype of the glove is able to help him apply force to the can and would then allow him to be able to kind of lift this object in a way that he wouldn't normally be able to do on his own. So we're very motivated about thinking about how we can restore function and restore independence using these types of technologies. And so one approach is to think about these as assistive technology. So when you wear it, it helps you do something like that last video. And the other approach is thinking about it as a rehabilitation technology. So something that you use, every day, but that helps you get better so that you eventually don't need the technology. And so we're very motivated at the moment, our team, to think about how we can kind of create a version of the glove that would allow someone to get, hundreds of repetitions of hand opening and closing in their own home, to practice kind of, or to kind of aid recovery of their hand, after they've had a stroke. And so one of the things that we, do a lot in our group, and that I thought I would highlight, is we do a lot of focus groups or, user interviews with people. And so even before we kind of developed the prototype of this at-home rehab device, we wanted to kind of get the perspective from end users to make sure that what we were thinking about doing made sense to them. So what you can see in the bottom right of this slide is a very quick mock-up prototype. So this is kind of not functioning, but it kind of shows the idea or the concept of what we would like to build. And then we show this, to people, and we get their feedback early on before we kind of go through and invest the time and energy in really kind of developing kind of the full system. So I think I'll take a pause here and maybe just ask people, like, why, what is the real benefit in developing these, looks like prototypes early on as part of a design and development process? Any ideas from people? Feel free to put your answer in the chat or raise your hand.
Abdul Rahman, would you like to unmute yourself? Okay, maybe we'll move on to the next student. Janvi, would you like to?
Yeah, because it helps to get the gist of the product that we are making, and it will help to know the drawbacks that will gonna come. So that's how making prototype before the initial period, that makes benefit. That's benefit for us. Yes,
Yeah, I think that's a great answer, and I totally agree. There's two reasons that we like to think about it. One is, when you invest a lot of time and energy, doing kind of significant engineering work, and then if you realize later on that it's, you might need to make changes, it's harder to make changes. One, it's kind of like you've already spent a lot of time. So, it feels like, oh, wow, we're going to have wasted a lot of time. And then secondly, there's a big emotional aspect to it. When you invest a lot of time into something, maybe you feel like you don't want to change your design because you've worked so hard on your design. So I think, developing kind of like quick early prototypes and showing them to end users and stakeholders is a really good way to kind of get that quick feedback that helps you kind of like adjust your direction, early on the project at a time when it's much easier to do that versus the later you do in a project. It's harder to do that. It's more expensive to do that because you have to go back and start again. And so, definitely would be a big believer in encouraging kind of early prototyping and sharing those early prototypes with stakeholders to get feedback. And so that was a really good answer. And so this is kind of what the prototype looks like. You can kind of see that here. And so we have a box that has the electronics and the pump. We have a glove that kind of has bladders inside it. And then we designed a software tablet that the user is able to kind of use and control the glove and interact with that as well. And so really at the moment when someone does rehab, they get about 30 repetitions of the hand in an hour. And so our goal with this technology is to enable people to get 10 times that. So, up to 300 repetitions in an hour of rehab. And some of the results we've seen so far are quite exciting. So you can kind of see that here. We had a poster at a conference So oftentimes when someone suffers a stroke, their hand is very closed and their fist is very clenched. And so, we're able to see with the glove that we can really help people, start to have a hand that has more movement and is able to be more open than previously. And the other thing that we do on this project, as we've done on many other ones, is looking at bringing this device to conferences. So as a developer, as an engineer, as a researcher, it's very easy to spend all the time in the lab. But it's really important to be able to go out to the world and talk to people. So one of the ways that we do that is we find a conference that would be focused on the topic that we are working on. And then we would bring our research there with either a poster or a prototype or both. And we would show it to as many people as possible who are, from the field, but not from our lab, and really kind of get their feedback kind of early on as well. And that just becomes very helpful in getting kind of broader perspective, from the world on what we're developing, so we don't get too siloed and focus only on what we are doing ourselves. We had some great feedback from this project, people that, really enjoyed it and using it, and they say that their hand feels better after using it as part of some of our studies. So we're very excited about this project and very excited about how it might actually kind of be able to move from the lab in the future and help people as well. This here is another prototype. So this is a shoulder device being used in combination with our glove. And so here you can kind of see the device inflating under his arm to help support his arm. And so he has some arm movement, but just not a lot. But now kind of using the device, he's able to move his arm in a way that he wouldn't normally be able to do. So another one of our volunteers who comes in and spends time in our study. And then here is this exciting side-by-side where you can kind of see, on the left video, having a challenge, basically kind of being able to perform this task independently, but then using the support, of our device, both the glove and the shoulder together, able to perform a task in a way that would allow him to be able to be much more independent, using our technology than compared to not. So, this is still all very early stage research, where we build these prototypes in the lab, and we're currently running studies with these technologies to evaluate and quantify, their impact and the benefit. But we've seen some very exciting results so far. So I'm going to kind of just have one last slide here. For people who might be interested in soft robotics, we have this website called the softroboticstoolkit.com. And you can go there. We have a lot of videos. We have a lot of materials you can download if you want to kind of get involved in this field and start to learn about, making soft sensors or soft actuators. And we have a bunch of case studies of people who have, built previous devices, so you can kind of see what other people have done. We also have some resources for educators, and we're working on some more of these in the lab. So, maybe teachers or other people could run programs, to help students kind of build some soft robots. So we have a lot of good information on here. And so feel free to check out this website. You might find it an inspiring way to get started in this field. So just go to softroboticstoolkit.com. And with that, I'm just going to, thank, and many people, like I said at the start. So this research is not the research of, a small group of people. It's a big group of people have worked on this. And so we really thank our study volunteers who come in and spend time in our lab, all of the lab members who worked on all these projects. We work with many other people at many other institutions. So we have many collaborators that we work with on these projects. And then, a lot of this work is funded by, federal agencies or by industry sponsors. And it also wouldn't happen without their support as well. So with that, I'm happy to kind of have the last few minutes, be some kind of questions and answers. But definitely really enjoyed the questions so far, and happy to spend another 5 minutes or so if there's any remaining questions on anything that we talked about today.
Great. Thank you so much, Professor Walsh. That was an amazing session. I'm so glad. Shout out to all of the students. Thank you all for being so engaged. You can send your questions in the chat, and then if you're open to kind of asking your question out loud, that would be great. So I'll just call in some students for the next 5 or so minutes, if that sounds good.
Sounds great.
Lillian, would you like to ask a question?
Hi, hello, good morning. This is Liliana, I'm from Brazil, and I would like to know if there are some programs for software developers.
for software developers, yeah. So we do a little bit of software development in our group, but it's not our kind of core expertise. I'm probably not the best person to advise on that. But definitely, I think software development is a really important part of the types of projects that we work on. So, oftentimes the software could be more low level. So if you want to be able to use sensor information to control motors, writing software on the microprocessor in that embedded system is really important. If you want to be able to reviewing sensor data and kind of making sense of sensor data, then maybe developing a software app for a phone or something like that would also be really important. So I'd say if you're excited about software and you're excited about this field, I definitely think there's a nice intersection between those two. And I think, I just don't have a quick answer on what is kind of like a best resource for doing that. But I think kind of becoming familiar with kind of programming with a Raspberry Pi or an Arduino is a really good way to get started.
Okay, thank you so much.
Thanks, Lillian. Ilham had an interesting kind of technically oriented question, so might be interesting to loop them in. Ilham, are you able to unmute yourself?
Yeah, thank you very much for this opportunity, Dr. Connor. What I wanted to ask is, how can the torque or the pressure output from this glove be varied or controlled to different applications? Like, for example, that need different grip strength, for example, holding a can to holding something heavier. How can it be varied or controlled?
That's a really good question. And I would say we've done a little bit of that, but we still have some work to do. It's a challenging but interesting research problem. So one of the things that we did before is we actually put sensors in the fingers. So we were able to measure how much pressure was between the fingers and an object. And so we were also able to show that we could kind of monitor that pressure and be able to kind of continuously increase the air pressure inside the bladders to kind of cause the hand to close tighter until we reached a certain kind of pressure amount. So that's one thing that we have done, but I still think we need to work on better ways to do that in the future. And one of the other approaches that people have tried to do is to be able to control the pressure in the glove based on the person's muscle activity. So for some cases, putting sensors on the skin enables you to pick up what the person is trying to do with their own muscles. And then you could amplify that with the kind of assistance from the glove. So basically kind of if you're detecting just a small amount of muscle activity, then you have just a small amount of air pressure. But if you see a big amount of muscle activity, then you try and have a big amount of air pressure. So that's called proportional EMG control. And so that might be another approach that would allow, to vary the pressure. But that's a very active research topic in, the question that you asked. So I think it's a really interesting area.
Great. We have another kind of interesting question from Zarek. Zarek, I can either ask your question or if you're able to unmute yourself, please go ahead.
Thank you. I am amazed for this technology, but my question is, what strategy you can apply to society in order to have this technology accessible for people?
Yeah, so, our role is to, within the research community is to show what's possible. And then, we need to partner with industry to bring it to the market. And I think one of the challenges for this type of technology historically has been accessibility because the technology is quite expensive. And so one of the things we definitely try and keep in mind when developing this technology is how do we keep it as simple as possible? And how do we use low cost components as well? So that at least there is a potential path forward to have the technology be affordable. And that's really the best that we're able to do. And then when it comes to kind of industry, for them, one of the big challenges has been, making sure that insurance companies see the value and are willing to kind of support it. And because to date, a lot of people would have to buy this on their own, and that can be very hard for people. So I hope in the future that as we run more studies and we collect more evidence on why this technology can really help people, that more insurance companies will be willing to cover the costs. So I think the two things are running studies to show the value and kind of designing technologies that ultimately have a path forward to being affordable. I think those two things are really important.
Great. Thank you so much. I know, Connor, that it's 11, and so just want to thank you so much for joining us. And thank you all for joining us from all different corners of the world. I know we had students speak up from Turkey, from Brazil. Really, really proud of all of you for showing up. And thank you, Connor. It was amazing. I know that the chat is really, it's on fire right now. Everyone just expressing their thanks for your joining, and how powerful it was to see the impact that your research has on the world of disability. So thank you so much for joining us. For Crossroads students, please stay on. I will be here to answer questions about the program for about 5 minutes afterwards. But Connor, back over to you.
Yeah, thanks. I'll just also say thanks to everyone for the great questions as well. I think it's also worth mentioning, when I was at the stage that you were all at, I didn't have a clue what I wanted to do. So don't look at life kind of has a way of kind of evolving. And I think for, my one piece of advice to people would be, if you're excited about this type of, engineering or technology or this application area, find a way to kind of just get involved and get started. And you can get started in a very small way and just gain some experience kind of over time. And then that gradually builds and evolves. And, don't look at, it always looks kind of very impressive when we see all these kind of great results, but it's taken a long time to get here for our group. And also for me, I didn't know when I was a high school student or starting my undergraduate what I wanted to do. And I think just getting involved early on in a research setting is a really good way to kind of get started and then see how things go and how they evolve. So that would be my one piece of advice to everyone today. But really nice, really great questions, and really enjoyed participating today. So thanks.
Thanks so much, Connor. Yeah, there's a lot of comments in the chat. If you would like to get in touch with Professor Walsh, please contact the Crossroads team. We can facilitate that for you. So please don't contact Professor Walsh directly.
Yep, that sounds great.
Great. Thanks so much, Connor, and hope to see you again soon.
Yeah, okay. Bye, everyone. Thanks.
Bye. Great. Just want to say, so proud of all of you for showing up today. I know that for some of you, it's very, very early. Where I am, at least, it was 7 a.m. when we started. For some of you, it's 9 p.m., 10 p.m. right now. So really, really proud of you and for showing up today. And just like, Professor Walsh said, maybe this is the first step in deciding kind of the fields you want to follow. Diane is asking, will we have meetings with teachers of social science, human rights? Yes, so this is the first in this seminar series. We have many, many sessions coming up for you, not just with professors at Harvard, but with professors at Stanford, MIT, as well as we'll be hosting some skill building workshops for you to work on your resume, personal statements that will be hosted by Harvard University's Career Services. So there's a lot in store for you. Thank you all for staying so plugged in, and we're really excited to bring more of this content to you. I know many of you probably have questions about the semifinalist selection process. So just want to say, again, please take a moment to celebrate yourself for all the hard work you've put in so far. And I will ask questions as they come in the chat, or if anyone wants to ask out loud, that's definitely fine too. For all of those who have received the notification that they have been selected as a semifinalist, congratulations. If you have not received that email, we are working in batches, so you will hear from us very, very soon. So if you haven't received an email yet, don't worry, it does not mean that your semifinal selection process is over. I hope that answers some questions. I know there's a lot of questions about what kinds of sessions are upcoming. Zersh, for example, has asked, will the seminar sessions be available for all the participants? Yes. So we have faculty who will be speaking from across a range of disciplines. So for example, Doris Summer is a professor of Latin American literature, and she will be leading a session in the next 2 weeks. And we will notify you of these sessions on our social media, but we will also be sending you a survey in engineering oriented. Although, do want to say that interdisciplinarity is a big part of what Crossroads is all about. You're all from such different geographic, cultural backgrounds, and I think having different academic perspectives is great as well. Talal, do you have a question?
Yeah, hello. Am I audible?
Yes.
Yeah, first of all, thank you for this amazing session. That was really very informative. So I have a question like, are we able to see our MCAT results? Because some of our fellow participants are able to see their MCAT results. But when I opened my like account, there was no result shown. So I don't know why is that.
Yeah, definitely. That's a good question, Talal. And we definitely want you all to be able to see your results. If you can contact the Aspiring Minds team, if you're not able to go through the portal and access your results, you should contact the Aspiring Minds team and they will be able to help you. But you should be able to find your results on the portal. Again, if not, please contact the Aspiring Minds team. Ikra, do you want to go ahead?
Hi, good evening.
Hi.
Chris here. I just want to ask that, is there any sessions on biological sciences? And kindly, can you please explain the main purpose and protocol of the faculty sessions, that what we are actually going to be study in the faculty sessions, and what is the purpose of faculty sessions?
Great. Ikra, that's a great question. So the purpose of these sessions is to be able to connect you directly to Harvard faculty members who are experts in their fields and who have a lot of industry experience as well, and to hear from leaders in their fields about different aspects that they're working on. And so we will have a variety of sessions. You can find them on our events page. Please keep checking that because we will be updating it regularly with all of these upcoming sessions. So the goal of these sessions is to connect you with Harvard faculty and for you to, I'm even hearing about Connor's amazing research, and the kind of story he told through this presentation was amazing. The second goal is that you can all then connect with each other. These kinds of academic sessions provide a foundation for you all to connect with each other. So maybe some of you in the chat have found a student across the world who shares the same academic and professional aspirations as you. I would love for you all to keep connecting with each other, keep discussing with each other, and motivate and encourage each other, and keep participating in these sessions because they, I think it's an amazing opportunity to be connected with these faculty members and ask them questions directly. Ikra, did that answer your question? I just want to kind of go back to the chat really quickly. The LinkedIn profile is a required part of your application to the finalist program. So if you have not built your LinkedIn profile yet, if you didn't put an actual link and you just put linkedin.com, please go ahead and try to build up your LinkedIn profile before we submit the rest of the semifinalist results. And if you are not selected as a semifinalist, you will receive notification of that in your email. However, I want to emphasize that not being selected as a semifinalist does not mean that your Crossroads journey is over. You still have access to all of these sessions, and I encourage you to keep showing up, keep staying engaged. The most valuable thing you can walk away from Crossroads with is the connections to your peers. So keep showing up, keep connecting. And for those of you who are not selected as a semifinalist, your Crossroads journey does not have to end there, and you're still a part of the Crossroads community. So I want to make that very clear. And if you have questions about any of that, please let me know. Abdul, would you like to ask your question? Or Nadima, go ahead.
Hello, everyone. I just want to know if we're not selected for the semi-finalists, if we'd be notified the email. Would you know about that?
So we have sent out one batch of acceptances to the semifinalist round. We will be sending another batch very soon. So you will know whether or not you have been selected as a semifinalist by the end of this week. And we will be in touch with all of you by the end of this week.
Okay, thanks.
Thanks for the question, Nadima. Quickly, just Abdul, go ahead. Are you able to unmute yourself, Abdul? Abdul, I think that the internet connection was lagging, so please, can you send your question in the chat and we'll be able to answer it.
I am unmuted. Do you hear me?
It's a little choppy, so it might be better if you sent it in the chat. Is that okay?
Hello? Do you hear?
Yes, Abdul, please send your question in the chat. We cannot hear you that well. Rancy is asking any tips for the recommendation letter. That is a great question. And that's exactly the type of question that you can direct to our team, and we will send you resources to support you. Like I mentioned kind of at our workshop before, you may either live in a place where asking for a recommendation letter is standard practice, or you may live in a place where you typically don't ask professors for letters of recommendation. So what I would recommend doing is connect with a peer on what is the best approach to ask a professor in your country, in your university, for a recommendation letter. For the recommendation letter, you can share with your recommender that the recommendation letter does not have to be long. It just has to come from someone who knows you quite well and who supports your goals and ambitions and knows your goals and ambitions. Someone who has seen you grow, someone who has seen you kind of develop as a student, as a teacher in any kind of way. Your recommendation letter, we would really highly encourage for it to be in English if possible. But the recommendation letter itself does not have to be very long. It can be 50 words, it can be 200 words, definitely does not have to be over 600 words. So just a page about you and why you would thrive as a Crossroads finalist. Rancy, I hope that helps. If I'm saying anyone's name incorrectly, also please correct me. That's very important to me. Someone asked what the submittable portal is. So the submittable portal is the submittable portal is where you submitted your initial application for the Crossroads Emerging Leaders program. So if you have applied to the program, you have an account on Submittable, and your application was through that platform. So please check the platform through which you initially applied to the program through, and that is going to be linked in the chat. Afi or Yashida, please go ahead. Yash, I know you have had a question for the last couple minutes, but I'm not seeing you now. So Yash, okay, there you go. Please go ahead.
Hello, I'm audible or not?
Yes, we can hear you.
So I received the confirmation letter, but I wasn't able to see the last date of submitting the documents. And then my second question is regarding the transcript from the university. My university doesn't provide an official transcript after 3 years of my graduation. I only have the result, digital result of each semester. So am I able to provide you that and get accepted for the next round, or am I not eligible for that?
Great question. First, Yash, just want to say congrats on being selected. I know that was a lot of hard work, a lot of stress, and I know it's been a hard time around the world. So definitely, please be proud of yourself and take some time to celebrate before you start working again. But that's a great question. The applications to the finalist program is due on June 9th. So on June 9th, you need to have completed the virtual interview. You need to have submitted your transcript. Your recommendation letter needs to have been submitted. And you also need to provide a resume, and you also need to provide a personal statement. So those 5 components need to be completed by June 9th. I hope that is clear.
Yeah, but
go ahead.
No, regarding my second question, I was asking.
Yes, second. Could you remind me?
Okay, yeah. So my university can't provide me a proper transcript till my graduation, like after my 3 years of my graduation. So
Okay.
I ain't able to get the transcript prior to 2025. So
great. That's a very, very good question. I'm sure also a question that I'm sure many of you are also experiencing challenges receiving your transcript from your university. In that case, you can provide a virtual grade report. We need a confirmation of, your kinds of grades through the years, your university enrollment through the years. And if it has kind of written somewhere where your graduation date is, that is also very helpful. An official transcript, I know, is very difficult for some of you to come by, so it does not need to be an official transcript. But like Yash said, you can submit kind of these virtual grade reports that you're able to get, or if you're able to go into the office and get a physical grade report, you can take a picture of it and upload it, whatever works best for you. If you have questions on whether your kind of transcript is suitable or not, please reach out to our team. Our team is here to support you. And we are also very understanding of, maybe you can get a transcript for this reason or you can't for that reason. So please write to us and we are here to support you.
And my one more question is, like, in India, we have 3 years of graduation. Like in Western countries and any other countries, there are 4 years of graduation.
Mm-hmm.
So, like, for considering the other round, like to qualifying this round, will there be bias? Like, I'm not saying biasness. Will there be more preferred to individual who have 4 years of graduation compared to 3 years or something like that?
That's a good question, Yash. Definitely not. The university system works differently in every single country. We will definitely not be preferring kind of a different structure over another. So that's a good question as well. I hope that eases some of your anxieties as well. I know, for example, there's different types of degrees depending on the country you're in. Please don't worry. We definitely want to welcome students from different academic backgrounds as much as possible. So definitely don't worry about your question.
Thank you.
Great. Adish asked, what is the most challenging thing in the final round? So that's a really, really great question. And it really depends on your kind of country and what might be challenging for you. The 2 things that are not in your control are the recommendation letter and the transcript. So it might be very hard for you to access the transcript from your university, and your recommender may not submit on time, or they may say, that they need more time, or they may not be willing to write a long, good recommendation. So those are the 2 things. So I encourage you to get started on finding your transcript and requesting your recommendation letter if you have been selected as a semifinalist as soon as possible, because the other pieces, I am confident that you can pull together yourselves. Many of you have already written short personal statements, so I know that won't be a huge barrier to your success. Many of you already have LinkedIn profiles and resumes. Many of you have, I've spoken with a lot of you in these sessions, so I know that the interview can go smoothly for you. But those 2 pieces, the transcript and the resume, which you are not completely in control of, those I think are the most challenging part. So get started on those when and as soon as you can. I hope that. Just the chat. So Zarek is asking, how can you schedule the interview? If you have been invited to complete the interview, you will receive an email from the AMCAT. So the Aspiring Minds team will reach out to you with login details, just as they did the same process that you all completed for your Aspiring Minds assessment. Great. So it's almost 11:30 Boston time. So I just want to go ahead and wrap up. I'm really glad that you're all kind of connecting with each other on LinkedIn. That's great. If you have questions, I know there's WhatsApp groups that are very active. So please try and identify one of those. Stay connected to each other. And for those who have been selected semifinalists, congratulations. So proud of you. Keep working. And for those of you who have not heard from us yet, be patient. Don't be too worried. You'll definitely hear from us soon. Thank you so much for joining. Afi, Ashra, is there any last questions? Great. Thank you all for joining and really looking forward to continue to getting to know you. Keep an eye out on our events page for the next sessions, and we will also send out a survey for you to mark your interest so you can receive emails about those sessions. Thank you everyone for joining. Great. I'm gonna leave it open for a second if you all want to type in the chat, but definitely reach out to us if you have any questions. Thanks so much.